3I Atlas is the third interstellar object discovered on July 1st, 2025, and it's relatively bright. So if what we're seeing is a reflection of sunlight from a solid object, its size, diameter, needs to be of order 20 kilometers. And that's problematic because it's 200 times bigger than the estimated size of the first interstellar object, Oumuamua, and about 100 times bigger than the second interstellar object. And that was 2I Borisov. So it's really surprising to see a giant rock because the mass scales as size cubed after seeing much smaller rocks before. And the other problem is that there isn't enough rocky material in interstellar space. Even if you were to take all of those rocks and package them in 20-kilometer objects, the first one to arrive to our neighborhood would be in 10,000 years. It's not over a decade time of a survey looking at the sky like the Atlas survey. So the question is, if such an object is so rare, what else could it be? And one possibility is that it targeted the inner solar system, meaning that there was a purpose for it to visit. It has nothing to do with the reservoir of rocks that move on random trajectories in interstellar space. And when one looks at the trajectory of this object, indeed it's aligned with the ecliptic plane of the orbits of the planets around the sun to within 5 degrees. The chance for that happening at random is 1 in 500. Right. But moreover, even adapting that path, the timing of its arrival is very fine-tuned. It comes close to Mars, Venus, and Jupiter. And the chance of that happening at random is 1 in 20,000. And it also moves on a retrograde trajectory that would allow it, if it maneuvered or if it released mini probes, it would allow it to reach the planets much more easily because the motion is opposite to the motion of the planets. And so any mini probe will not need to chase the planet as it moves around. So there are reasons to believe that maybe this trajectory is fine-tuned by some intelligence. It also came from the direction of the center of the Milky Way galaxy, which is crowded with stars, so we had a hard time finding it. And my point is, we should monitor it to figure out what its nature is. Now, there were spectroscopic observations of this object, and the conclusion was that the object is red. The reflection of sunlight is reddened. But that's also a property of the surfaces of objects in the Kuiper belt. They are also red because they develop organic molecules as a result of the bombardment by cosmic rays or ultraviolet light. And if this object moved through interstellar space, it was exposed to the same environment. But there is some glow around the object, and on July 21st, the Hubble Space Telescope imaged the 3I Atlas, and one can see that there is some scattering material, medium, around it out to a few thousand kilometers. And now the question is, why don't we see a cometary tail? Because comets, often when they have a coma, the dust particles that make up the coma, the cloud of dust around a comet, they are pushed by radiation pressure from the sun, and they trail the object. I calculated it would take 1 day for micrometer-sized particles to get pushed by sunlight and eventually appear as a cometary tail. We don't see that. Also, I calculated how much material is needed to supply the amount of dust that we have in that glow. And it turns out that you can supply that glow in a steady state for a period of 6 months, which is pretty much the duration of the passage of 3I Atlas through the inner solar system. You can do that for 6 months if you ablate a layer that is thinner than a millimeter on the surface of an object of 20 kilometers size. So it could be just dirt on the surface of a solid object, especially if the object was exposed to collisions with dust particles along the interstellar journey. They may have fragmented the surface a little bit, and what we are seeing is just the release of that those tiny fragments or dirt that collected on the surface of a solid object. So it's not at all clear to me that this is cometary material that we are seeing in the scattered light. And moreover, there is no tail. And I actually created a model this morning where I derived the reason that there is an edge of a few thousand kilometers to this glow. It has to do with the existence of zodiacal dust, some material in the region that this object is passing through, which is basically stopping the outflow from the object of dust particles and then mixing them at very faint levels that we can't really see as a cometary tail. So the bottom line is very little material is actually creating this glow, and it appears only in front, the side facing the sun, and not behind the object as often seen in comets.
Sure.
Then I realized also that we could take advantage of the fact that it comes close to Mars and close to Jupiter. So it will reach 29 million kilometers from Mars on October 3rd, 2025. And I encouraged the team operating the Mars Reconnaissance Orbiter around Mars to look at it, because they have a camera called HiRISE that is 0.5 meter in diameter and has pixels that are 30 kilometers in size. So at the distance that the 3i Atlas will be. So they can, in principle, get us close to the nucleus of this object, not necessarily a resolved image. And also there is a spacecraft orbiting Jupiter called JUNO that was supposed to end its life on September 15, 2025. And I suggested instead of pushing it into Jupiter, we should push it away from Jupiter and use it to probe Jupiter when it passes close, when 3i Atlas passes close to Jupiter within a distance of about 25 million kilometers from this probe. Even if it has only 10% of the initial fuel, it can get to within 25 million kilometers from 3i Atlas and give us more information than we can get from Earth. And I had a phone call from Congresswoman Anna Paulina Luna, who asked me for an update about 3i Atlas, and I mentioned the opportunity to use JUNO in March 2026. And she was very excited about it and wrote a letter to the head of NASA, Sean Duffy, the Secretary of Transportation. He's the interim administrator of NASA, and encouraged NASA to actually look into the possibility of using JUNO to probe 3i Atlas. So I very much look forward in the coming months to getting more data so that we can figure out the nature of 3i Atlas. And in July, just after 3i Atlas was discovered, I suggested a new scale for interstellar objects that is now called the Loeb scale, and there is a scientific paper on the Astrophysics Archive about it, where 0 identifies an interstellar object as natural, like a rock, a comet or an asteroid, and 10 suggests a technological origin. And right now I rank 3i Atlas as a 4. But if we get more data and it looks as if it does some maneuver or emits artificial light or broadcasts a message, the stock market may crash. We need to establish an international committee that will decide how to respond, because it's very different than getting a message from far away, a radio signal where you have plenty of time to decide what to do about it. Here, if you have a visitor to your backyard, it might actually show up at your front door, and you have to decide what to do about it.
So should we send a message, attempt to send a message? What's your thoughts on that?
I also wrote an essay about the question of should we message 3i Atlas, and my conclusion was that we should wait another month to figure out whether it's a comet or it could be technological, because it makes no sense for us to send a message to a rock. But it would be an interesting way to start a conversation. And I was asked what would the message be by a reporter, and actually the BBC liked very much what I said. I said the message could contain 6 words. Hello, welcome to our cosmic neighborhood, peace.
Yes.
And the question is, what language would one use? And there are languages that are easy to decode. We should use some way of decoding this meaning and hope that if there is a technological object, it's equipped with either biological intelligence, natural intelligence, or artificial intelligence that can easily figure out what we mean.
Wow. There's a lot going on. So what date do you think we will know more? We can decide whether it is just a comet.
I hope that by the end of September,
Oh,
we will
wow.
have enough data. The Webb telescope already looked at 3i Atlas, but the data is not public. And the next time the Webb telescope is scheduled to look at 3i Atlas is in December
Okay. All right.
2025, when actually we will be closest to it. But that is relatively late in the game. I
Yeah.
would rather know the nature of this object before its closest approach to the sun on October 29th. And we
Okay.
should see.
Okay. And so why is that data not been made public by James Webb
Uh,
Telescope?
This is the policy of scientific data collected by the Webb telescope. In
Mm,
principle, the team that has that data can keep it to themselves for 3 months. But
yeah.
it would be very helpful if they were to release their findings much earlier than that. Because if you are looking at a distant galaxy at
Yeah.
the edge of the universe, a few months is not a big deal. Nothing much happens there.
Mm,
But in the context of an interstellar object, 3 months is pretty much the amount of time where we can collect the most data on it. So I would really want to know what the Webb telescope saw, so that we can design additional uh, observations accordingly. Like if there is something really unusual about it,
mm.
it will guide us as to what we want to observe in the coming months. And therefore, I would prefer to see the data. I'm already analyzing the data from the Hubble Space Telescope.
Mm,
It's limited in scope, but
mm,
it's very informative. And I constructed this morning, before my morning jog at sunrise, I constructed a model that can explain what the Hubble Space Telescope saw.
Wow, okay. And just to clarify, when's it closest to Earth? When will it?
So the interesting fact about the 3A Atlas is that it gets closest to the sun on
Mhm.
October 29th, when the Earth is on the opposite side of the sun. So we won't be able to observe it. And it will actually be away from us by a relatively large margin. We will get closest to it when we move to the other side of our orbit around the sun
Yeah.
on December 19th, 2025. We will observe it from the closest distance of 1.8 times the Earth-Sun separation.
All
But
right.
obviously, if it were passing close to us, as it does close to Mars, for example, then we would see it from a distance that is almost 10 times shorter. And that would have given us an amazing view, because
Mm.
it's supposed to be much brighter as it gets close to the sun.
Okay, brilliant. And when will you find out about Juno? Is so when will you find out if Juno can be?
Yeah. So
Yeah.
I very much hope that NASA will employ JUNO to
Mm,
probe 3I Atlas, and they need to do it by the middle of September. The
mm,
original end date of the mission was the middle of September, and I suggested extending it by at least 6 months. And Congresswoman Anna Paulina Luna
mm,
embraced that recommendation. She said that she will support
mm,
funding at $15 million another 6 months for this mission. And the only question is whether the team of JUNO or the
mm,
NASA higher administration will go along this recommendation. Obviously, there is this tendency
mm,
of scientists to keep doing what they were doing before. And
mm,
so what is special about this situation is that the mission was supposed to end. And
mm.
here I'm offering a way to give it life support for another 6 months.
Wow. Okay, thank you. And just going back to, you mentioned the Oumuamua, which I know you investigated quite a lot. Do you think we missed the trick there, investigating that properly, in your
Yeah.
opinion? Mm,
When the first interstellar object Oumuamua was discovered on October 19th, 2017, astronomers assumed that it's a comet.
mm,
And therefore, there is not much reason to follow it intensely. And so we had the limited data, and then it became we saw it on the way out
mm,
from the inner solar system, and it became too faint for us to observe just a few months after it was discovered.
mm.
And it turned out that it's not a comet because there is no cometary tail. There was no gas or dust observed around it. The Spitzer Space Telescope looked at the object and put upper limits on that. And of course, comet experts now argue that it's a dark comet, meaning it's a comet where the cometary tail is invisible.
Mm.
And I behave like the kid in Hans Christian Andersen's tale that says, no, if it doesn't have cometary tail, it's not a comet. If the emperor has no clothes, then there are no clothes. And the issue is that the cometary tail, the evaporation of a comet, is the signature of it. So claiming that there could be a type of comets that is dark is just like saying that an elephant
Mm.
is a zebra without stripes. It's a completely different animal.
Yeah, I've got you. So, I mean, do you think these two objects could be related in some way?
It may well be that Oumuamua was just a surface layer of a technological object,
Mm,
that was torn apart and that may be flying through space because
mm.
there are spacecraft out there,
Yeah.
and we just underestimate how close they are to us.
Mm,
It could have been also some reconnaissance mission that preceded the
mm,
visit of 3I Atlas.
mm,
We will never know because it's too faint now, but with 3I Atlas, the benefit is that we discovered it coming towards the
mm,
sun, and therefore we have a few months to continue observing it. So one of the reasons I
mm,
am advocating that it could be technological is in order to convince my colleagues, the observers, to
mm,
take as much data as possible,
mm,
because if there are anomalies that they would find, it wouldn't be possible to
mm,
shove them under the carpet of traditional thinking. The mistake made by the Vatican when Galileo Galilei
mm,
said, look through my telescope and you will see the moons going around Jupiter. Instead of putting him in house arrest,
mm.
if they said, we will build a better telescope than yours and resolve the region around Jupiter to prove you wrong,
Yeah.
if they were to do that, they would have corrected themselves much faster than it took them 350 years after he died. They announced in 1992 that he was correct. And that was embarrassing
Yeah.
for them to admit that they were wrong. And my recommendation is if you believe in a paradigm like
Mm,
this object must be a comet, take as much data as possible to
mm,
demonstrate that it cannot be anything other than a comet. And then at
mm.
the end of the day, if it's not a comet, you will not be able to escape that conclusion.
Wow. Okay. Thank you so much. I mean, this is very exciting.